Hello, and welcome to Skalar. My name is Al Yates, and I am the East Coast Division Manager for Skalar US. Today, we're here on the production floor of our manufacturing facility in the Netherlands. Today, we're going to be doing our fourth installment of our FAQ, our frequently asked questions, and we're going to highlight our SAN series today. So we're going to head up to our validation floor where we validate each of these systems chemically before they go out the door. So we'll see you up in the lab soon. Welcome back. We are now here on the floor of our validation lab where each of our SAN series instruments are fully chemically validated before they ship out to our customers. There are strict guidelines that they must pass certain criteria before they ship out to our customer's door. Basically, we're creating an out-of-the-box instrument for you all. So getting right to our questions, our first question we get the most asked is, for inline digestions, how do you make certain you get a representative sample with particles and that it does not settle out over time? So, as I was saying, if we look at our auto sampler here, what we see is when we're running, especially for total nitrogen and total phosphorus, we have to make sure that we actually pick up a representative sample of that sample, and a lot of times they do have particles. And if we don't pick those particles up, then tests like total nitrogen and total phosphorus, our results do not compare to those of our offline manual digestions. So what we see on the auto samplers, I have two very important pieces of our auto sampling process. We have a mechanical stir that basically agitates that sample so that those larger particles don't settle out. Secondarily, we also can add the homogenizer to it, which is basically a sonicator. So we all know what a sonicator is, and we take those larger particles and break them up so that that way they can actually be aspirated via the needle and over into the digestion step of the analyzer. On to question number 2. How do you guarantee a full digestion occurs with the inline digestion for total nitrogen and total phosphorus? So this is how we handle the inline digestions on our system. So once the sample is brought over from the auto sampler, it's going into the digestion step. And what we do is we apply a back pressure to that. So we put the system under pressure. That allows us to get the temperature up to 110 degrees C in line without basically popping off tubes. In doing so, we're emulating what we would do on an autoclave. So it first comes in, we add the persulfate. From there, we're sending it through a UV destruction coil to basically break down the organic forms of nitrogen and phosphorus. And then from there, we send it into that 110 degree digestion step that basically emulates what we do in an autoclave with the temperature. And then from there, we break down all of that nitrogen and phosphorus into a form that we can easily colorimetrically determine on the module. So on to our third question. How much space does the inline distillation hardware take up on the bench? So for that question, we go to our instrument. This is an example, this is an ISO form of total cyanide with inline distillation. And as you can see, all of our distillation is done here above board. This heat reactor here that's doing the distillation, all the oil is contained within the reactor itself. So we don't have any kind of external. As you can see, there's no external. Everything is contained within here. We have a circulating cooling that will basically either by a circulating pump, or we're also just going to use cooling water from my tap. And that will chill this back down and then just discharge back into my sink down to the waste. So basically, it's a very simple process of our system. There's nothing external, as I mentioned, that takes up space with any of the distillation process. And now our fourth question. Can you use a detection head for other parameters on your system? Well, that answer is easy. So yes, we can use these detectors. They're not designed for one particular chemistry or wavelength. So as you notice here, what we've got is we have a flow cell, and in this case, we're doing nitrate plus nitrite, which we're measuring at 540, and we have our 50 millimeter flow cell here. So if I needed to, let's say that I didn't have the second flow cell back here, and let's say I wanted to run my cyanides, well, I can very easily take the cyanide flow cell along with its wavelength filter, and I can remove the one I have here for ammonia. I can easily move the ammonia wavelength filter, also its flow cell, and just place the flow cell inside of the slot right there, and my wavelength filter, and voila, I'm ready to go. So there's no special alignment that's needed for changing your flow cells out. They can fit on either side. The main part is to just understand in your software where the flow cell is oriented, and your correct wavelength, and away you go. And now on to our fifth and final question. How do you run your system overnight unattended? Well, that's easy, and I'll show you. So we're here on the unit, and essentially what happens is once all of our samples have been analyzed, we tell the system that we want to basically go to a shutdown mode. What that means on our system is we have a series of rinse valves that change over from all of my reagents, and you'll see the rinse valve here. They're connected to my pump tubes, so the system is still pumping its reagents. Then the valve switches over and pulls in DI water and rinses for a determined amount of time. Then once that's done, the pump will stop. It also does have the auto platen release. So once we've rinsed this out completely, we'll basically release the pressure on our pump tubes so that we're not wasting our pump tubes. And then from there, I also can control all of my external hardware, such as a UV lamp, my heaters, my detectors, gas flow if I'm running things that require gas. I'll turn all of that off and park it. One of the key things that we talk about too is our valves. So if we look at our valves, we have a plunger system, and it's not an electronic lead style valve, which is very critical because those are prone to clogging. So the apertures on the inside of this rinse valve you see here are fairly large. So to plug these are very difficult. They're mainly maintenance free. So once a year we recommend on your PM visit by a Skalar engineer, or your users can do it itself, is you remove the tops of these valves, and these little plungers come out, and there's a series of O-rings that we replace annually to make sure that they're sealing really well as they slide. Because in essence, if you can visualize, they're just pulling these rinse valves up and down to divert the flow from reagent to DI water to rinse the system out, and then vice versa. So that is how we truly basically shut down our system and leave it running overnight while we're home enjoying our afternoon. So thank you for joining in, and we hope we've answered all your questions. But if not, certainly you can find us on Skalar.com, and thank you for joining in.